Hi again, I'm Sharif presenting on behalf of Team 1, which consists of Jazzy, Marissa, Henry, and myself. Last week we talked about a general overview of the criteria for this project and everything that it would entail. However, this week I'd like to go a little more in depth and show off some machine assemblies we created in SOLIDWORKS and our reasonings behind those designs. We're then going to take a look at the final archetype for the project we intend on using during the competition. First off, I'd like to quickly remind you of all the tasks that need to be completed. There's Black Knight removal, shrubbery gathering, grenade launching, egressing, and collecting the Holy Grail. Now in this animation, it's assumed that the machines egress in time. The important thing to remember here is that the machines will be competing against each other. As such, time and task management are of the utmost importance if the team wants to win. Therefore, making sure that all the grenades are launched and that the machine egresses is probably the most important task, since that task can't be disrupted by other teams. Black Knight removal is also tricky, because a team's home zone can have anywhere from 0 to 3 Black Knights, which can have a huge impact on points gained. This hypothetical test run demonstrates the impact that other teams can have on the points gained. It's for that reason the team wants to capitalize on any negative consequences we can cause to the other teams competing against us without sacrificing the task completion process itself. Now, in order to understand how we got these ideas, the team constructed several preliminary ideas on some concepts to complete each of the required tasks. Here you see some basic starting points that we use to construct each of our designs. They all vary on accuracy, speed, reliability, and cost. We then combine some of these subsystems to construct full machines to try and complete the required project tasks. And after this, we'll be ranking our designs to see how they stack up against one another in terms of completeness and feasibility. After overviewing some basic methods of task completion, we then proceeded to construct full assemblies. Now we'll be going into more depth into each machine's design, but for now you can see how some of our machines rank up against each other. In these categories, it's clear that our chosen design, the slider, works best. This is because most of the mechanisms that it features we've either worked with ourselves, or it's because we've seen other teams utilize those designs successfully. And while the other designs come in close, they don't quite match the slider's strengths or the fact that its design has been proven to work. They are, however, more unique than the slider, which is good considering that design is also a customer requirement. Here you see one of our alternative designs, the telescope. It features an arm powered by mouse traps that swings to either knock the Black Knight out of our zone, or at least put it partially in the other team's zone. This aspect of the design is especially useful for the competition, since any scooping device, if it doesn't work, wouldn't harm the other team. The shrubbery collecting is done by falling arms retracted by strings in a DC motor. A platform would then go out via drawer slide to release the grenades, and a scissor lift-esque gripper would then grab the Holy Grail. The problems with this design is perfecting the scissor lift and making sure the platform launches properly. The robot design works by sending out a platform via pneumatic actuator. The launching of the robot would drop the shrub gathering arms via a bar attached to the front of the robot. The arms would then sweep via string and motor. The robot would also return to the platform by the same method. In addition, the robot would be equipped with a scooper to pick up the Black Knight and a mechanical gate to launch the grenades. There would also be a claw on top of the gripper whose height would match the Holy Grail. It would then rotate via a string attached to the end of it. The goal would be to just knock the Holy Grail off towards the home team's direction, but should it not work, it would not allow any other team to consistently capture the Grail. Now here's another one of our designs, the Feeler. Actually, that name didn't do too well, so we changed it to the Ant. Anyways, the Ant has arms that fall horizontally, and these arms have buckets at the end that would scoop the grenades into our home zone. The arms on top would be activated via mouse traps that fold out to the center, and the unfolded arms would also have a piece of rubber material that would grab onto the Holy Grail. The Black Knight would be scooped via the scooping arms, and the grenades would fall down a decline cylinder. The hardest part of this design is certainly the Holy Grail attachment system. Finding rubber that works this way would be extremely difficult. Now here's our final design, the slider. It's based on the design mechanism that we've used multiple times and have become accustomed to. A platform holding a Black Knight scooper and a grenade launcher would roll to the beast layer. While this is happening, the shrubbery arms would fly out and start pulling in the shrubbery into our home zone. When the platform reaches the beast layer, the shock would cause a Grail gripper to fly out via mousetrap to fall on top of the Holy Grail. The most unreliable parts of this design are the Black Knight scoop and the Holy Grail gripper, but if the gripper at least falls on top of the Grail, it would disrupt other teams' attempt to capture the Grail. Overall, this design seems the most feasible, reliable, and modifiable should there be any need to change the parts of the design. I'd like to thank you all for your time, and if you have any questions, you can ask them now. Thank you.